we are continuing in lesson 1 and 0 and negative exponents. That's what we saw today in class. We're going to solve the following problem. So it says, study the example problems showing how to simplify expressions with 0 and negative exponents. Then solve problems 1 to 12. So for example, the first example they are given to us is simplify 217 to the 0 power. We learned today that if you have a power of 0 is equals to 1, wherein the value of the variable is different than 0. So in this case, 217 to the 0 power is equals to 1. Then we have negative exponent. Simplify 15 to the negative 2. So in general, in this case, remember the formulas have n to the negative a is equals to 1 over n to the a, where n has to be different than 0. And it applies this way too. So for example, n to the negative a is equals to 1 over n to the a. And if you have 1 over n to the negative a, you can have n to the a. So it works both ways, and moving to the numerator, or if it's negative in the numerator, moving to the denominator. So in this case, 15 to the negative 2 is equals to 1 over 15 to the second power. Knowing those properties, let's solve the following problems. Okay? Remember that we are going to try to do it step by step so you can follow along. So they are asking for problem number 1, simplify 100 to the 0. That's a no-brainer. That's no thinking. Using the property n to the 0 equals to 1, 100 to the 0 equals to 1. Number 2, write negative 32 to the negative 2 as an expression without negative exponent. So in this case, what I'm going to do, okay, so you have negative 32, that's your base. The exponent is negative 2. So if I apply the property n to the negative a is equals to 1 over n to the a, this one will be equals to, I'm going to write it here. So negative 32 to the negative 2. Don't worry about this negative inside the parentheses. Is the negative exponent the one that you need to focus? So this is equals to 1 over negative 32 to the second power. Okay, that's problem number 2. Problem number 3. You need to write 1 over 7 to the 6th power as an expression with a negative exponent. So what they are asking me to do, move that 7 to the 6th to the numerator. So in this case, if I have 1 over 7 to the 6th is equals to 7 to the negative 6. I move this 7 to the numerator. Okay. Number 4, compare 8 to the 0 and 8 to the negative 2. Which is greater? Explain your reasoning. Okay? So in this case, if I have 8 to the 0, I know is 1. And if I have 8 to the negative 2, if I have 8 to the negative 2 is equals to 1 over 8 to the second power. Okay? So in this case, the question is, what is 8 to the second power? So is 1 over 64. And if you divide 1 divided by 64 is equals to 0.015629 and so on. Remember that 8 to the 0 is equals to 1. So 8 to the 0 is greater than 8 to the negative 2. So what can you write in that line? 8 to the 0 is greater, possibly, explanation could be, a possible explanation, it could be 8 to the 0 equals to 1 is what we wrote, and 8 to the negative 2 is equals to 1 over 8 to the 2, which is less than 1. Okay? So we did the reasoning here, and then you have to write something, and then you have to write a possible explanation. Number 5, you have to simplify 12 to the 0 times 12 to the 6. Write your answer using an exponent. Explain how you found your answer. Okay, so in this case, I have, we have different ways to approach that problem. So I'm going to use this piece of paper here to solve that problem. So I have 12 to the 0 times 12 to the 6 is equals to. If I use the property n to the a times n to the b equals to na plus b, this one will be 12, 0 plus 6 equals to 12 to the 6. Okay? That would be one way. What would be another way? So if you have 12 to the 0, 12 to the 6 equals 2. What is 12 to the 0 by definition of n to the 0 equals to 1? So this one is 1. So you have, in this case, 1 times 12 to the 6, identity property of multiplication, equals to 12 to the 6th power. Exactly the same solution, different steps. So explain how you found your answer. So the solution is 12 to the 6th power. Okay? Possible explanation, you have that 12 to the 0 is equals to 1. Okay? And 1 times 12 to the 6 is equals to 12 to the 6. That's one way to write a possible explanation. We did it in a separate piece of paper. So, number 6. What is the value of x in the equation negative 35 to the x power equals to 1? You need to explain. I'm going to use the piece of paper again, okay, to explain that problem. So remember which property are we using, that it doesn't matter the number, but if it's elevated to this number is equals to 1. So remember n to the 0 equals to 1, where n has to be different than 0. So that's the property. So which number is the value of x? So in this case, if you have negative 35 to the x power equals to 1, then you're going to have that x is equals to 0, because negative 35 to the 0 is equals to 1. So in this case, what is the value of x? X is equals to 0, okay? You need to explain, they're asking you to explain. So in this case, you have any non-zero, remember that n cannot be 0, n cannot be 0. Any non-zero number to the power of 0 to the power of 0 equals 1. Okay? That's 1. So let's do the following, number 7. Number 7 in this case, write an expression using exponents that is equivalent to each of the following expressions. So you have 5 to the negative 3. We have a property. So if you have n to the negative a is equals to 1 over n to the a, where n has to be different than 0. Okay, n has to be different than 0. So if you have 5 to the negative 3 is equals to 1 over 5 to the 3rd power. Then I have b, negative 16 to the negative 2, exactly the same property. So you have 1 over negative 16 in parentheses because it's negative to the 2nd power. And then I have c, I have 1 over 8 to the 4. So I'm going from this one to this one. So I have 8 to the negative 4. That's page 7. Now I'm moving to page 10. They are asking me, simplify the expression negative, 52 to the negative 5. Then write it as a repeated multiplication. So what I have in this case, so you have 52 to the negative 5. So I know this one, 52 to the negative 5 is equals to 1 over 52 to the 5th power. And then they're asking me, then write it as a repeated multiplication. So this is equals to, how many times I'm going to multiply this fraction? 5 times. So I have 1 over 52 times 1 over 52 times 1 over 52 times 1 over 52. How many times? 5. 1 over 52. 1, 2, 3, 4, 5. And that's what they are asking us to do. Number 9. Write an exponential expression. Write an exponential expression that is equivalent to 4 to the 14 to the negative 2. Okay, so I'm going to apply the property. You have n to the a to the b power is equals to na times b. So I have 4 to the 14 to the negative 2 equals to, in this case, is 4. What is 14 times negative 2? It's negative 28. Okay? So what can I write on that case? So this is equals to 1 over 4 to the 20a, okay, using the property. Or if I take this one, the original one, okay? If I take the original one, so 4 to the 14 to the negative 2 is exactly the same as 1 over 4 to the 14 to the 2nd power, okay? So this one is the same. So those are the expressions that are equivalent to this one. Number 10, is 6 to the negative 2 positive or negative? Explain. Is 6 to the negative 2 positive or negative? Explain. Well, it's positive. So I have 6 to the negative 2 is equals to 1 over 6 to the 2nd power. That's a positive number, okay? That's a positive number. So this one is equals to 1 over. What is 6 times 6? Because 6 multiplied 2 times. 6 times 6 is 36. And 1 over 36 is positive. Number 11, you need to write 9 to the 0, 9 to the 3rd, and 9 to the negative 2 in order from least to greatest. So I need to write it from the smallest number to the biggest one, from least to greatest. So in this case, let me evaluate those numbers. So I have 9 to the 0 equals to 1 by property. Then I have 9 to the 3rd power is equals to, it's a big number. Okay, 9 to the 3rd power is 9 times 9 times 9 equals to 729. Okay, and then I have 9 to the negative 2 equals to, in this case, I have 1 over 9 to the 2nd power, and this is equals to 1 over 81. For sure, this is the smallest number. It's a fraction. So if you divide 1 divided by 81, so it's equals to 0.012. This is 0.012 and so on. Okay? So the smallest number will be, I can write it in this way. Solution here. So I have 9 to the negative 2. That's the smallest number. Then what is the next one? 9 to the 0. And what is the biggest one? 9 to the 3rd power. Okay? And that's the solution. That's what you need to do. I have an application problem now here. I have Lisbeth says that negative 12 to the negative 3 power equals a positive number because the product of two negative integers is positive integer. Do you agree? Use what you know about exponential expressions to explain. In this case, I'm going to say I do not agree. So I'm going to put a no. No. Okay? What is the possible explanation? So let me do some math here. So I have negative 12 to the negative 3rd power is equals to 1 over negative 12 to the 3rd power. Positive, right? If we put this fraction here, negative 12 to the 3rd power. If you multiply negative 12, I'm going to do it here, negative 12 times negative 12 times negative 12. Is negative and negative is positive. Positive and negative is negative. So you're going to get a negative number. They're not asking me for that big number. So negative and negative is positive. Positive and negative is negative. So in this case, it's going to be a negative solution. So in this case, you can write here a possible explanation To simplify an exponential expression, you do not multiply the exponent and the base. Okay? You do not multiply the exponent and the base. So for example, is what we just wrote over here. So in this case, I have 1 over negative 12 to the third power, which is equals to 1 over negative 12 times 1 over negative 12 times 1 over negative 12. And negative is positive, times negative is equals to negative, which is a negative number. Okay, it's a negative number, so it's not true for number 12. Okay, let's move to page number 9 of your homework. Solve the problems. Remember that we had these ones in the notes in the video that I posted. So we're going to look at the equations below. Tell whether each equation is true or false. So solve the problems. You may have to apply more than one rule when working with exponents. So we're going to apply more than one rule. So in this case, what we are going to do. Okay, so problem number 1, look at the questions below. Say true or false. So I have 3 to the 5th power times 3 to the 7th power equals to 3 to the 31st, 3 to the 35 power. Is that true or false? When you have the same base, you add the exponents. You do not multiply. They multiply. 5 times 7 equals to 35. So this one is false. You need to add them. So it's 12. 5 plus 7, 12. Then the second one. So I have 6 to the third power times 3 to the third power to the second power. Let's do that problem here. Okay? So I have here, they are asking me if 6 to the third power times 3 to the third power to the second power is equals to 18 to the 6th power. We need to figure out. Different bases, equal exponents. So I have 6 times 3. In this case, we are going to have 18 to the third power to the second power. And base is the same. 3 times 2, 6 is the same number. So is true. Next one. So I have 7 to the negative 6 times 1 over 7 to the 4th power is equals to 1 over 7 to the 10th power. Let's check this one. So C, I have 7 to the negative 6 times 1 over 7 to the 4th power equals to 1 over 7 to the 10th power. I haven't made an example where I add the denominators. So what I'm going to do is extend that example. I'm moving this 7 to the 4 to the numerator. So I have 7 to the negative 6 times 7 to the negative 4 equals to 1 over 7 to the 10th power, okay? So what I'm going to do, same base, 7, negative 6 plus negative 4 equals to 7 to the negative 10. And if I move this negative exponent to the denominator, I'm going to have 1 over 7 to the 10th power. So in this case, it's true. C is true, okay? Let's do D. I have 4 to the 4th power times 4 to the 2nd power equals to 4 to the 6th power. That one is just same base. We add the exponent. 4 plus 2 equals 6. True. We have E, 13 to the negative 4 over 13 to the 4 equals to 13 to the 0. That one is not true. It's false. Why? You have 13 to the negative 4 over 13 to the 4 equals to. The property that they are trying to use is same base, we subtract the exponent, so negative 4 minus from the formula, and then you have 4. So this is equals to 13, negative 4 minus 4 is equals to negative 8. So that's the solution. So in this case, it's false. And then I have F. It doesn't matter what you have inside the parentheses. If it's to the 0 power, everything goes to 1. everything goes to 1. So this is false. Since you saw that 0 there, everything is 1. So this one should be 1. Okay? That will be 1. Number 2, in page number 9, I have that Tyler simplified the expression 5 to the 4 times 5 to the negative 9. All of his work except his answer is shown below. So I have the process. Remember what you know about negative exponents. Which expression is correct answer for Tyler's work? Which one of these ones is the correct? So I have same basis. We add 4 plus negative 9 is equals to negative 5. Property n to the negative a is equals to 1 over n to the a. So in this case, the negative becomes positive, so it's 1 over 5 to the 5th power, so it's b. Okay, b will be the solution. Let's complete the table. Expression, simplified expression, are the bases equal? Are the exponent equal? That's the questions that you need to ask yourself. So in this case, bases are the same, so we add the exponent. 4 plus negative 2, so it's 10 to the 2nd power. 4 plus negative 2 equals to 2. So it's 10 to the 2nd power. Bases are different, exponents are the same. So I have, I'm going to do it here. So 5 to the 4 times 7 to the 4th power. So it's 5 times 7 to the 4th power, and 5 times 7 is 35 to the 4th power. And then I have this one, same exponents, different bases. So I have 2 times 4 is 8 to the 7th power to the 3rd power. 7 times 3 is 8 to the 21 power. Okay, that will be the solution number 9. Number 10, page number 10, problem number 4, you have to simplify 32 to the negative 1 times over 32 to the 6th. Write your answer with a positive exponent. So what we are going to do, I'm going to show you work. So I have 32 to the negative 1 over 32 to the 6th power. I'm going to move this denominator to the numerator. So this is equals to 32 to the negative 1 times 32 to the negative 6. Bases are the same, so we add the exponent. So 32, negative 1 plus negative 6 is addition of negative numbers. So I have 32 to the negative 7th power. Remember, answer your question with positive exponent. So this equals to 1 over 32 to the 7th power. Okay? So in this case, your solution is 32 to the negative 1 over 32 to the 6th power is equals to 1 over 32 to the 7th power. Number 5, you need to write 9 to the 6th as a power with base of 3. Okay, so in this case, I know 9 is equals to 3 times 3. If you have 3 times 3, here, I'm going to write this one. So 9 to the 6th is equals to 3 times 3 to the 6th power. They are asking me base of 3. 3 times 3 is 3 to the 2nd power to the 6th power, okay? Because I'm multiplying 3 2 times. And applying the property, 2 times 6 is equals to 3 to the 12th power, okay? Remember, you asked the question, what are the factors of 9? Then I have number 6. Which expression is equivalent to this one? Okay, same base. Same base, different base, same exponent. So I have 3 times 5 is 15 to the 4th power to the negative 3rd power. Then this is equals to 15. 4 times 3 is equals to negative 12. So this is equals to 1 over 15 to the negative, positive 12 power. So what is the solution? C. Tanya, in this case, choose B as the correct answer. How did she get that answer? Okay? In this case, I can say that Tanya, if you get negative 48, she used the order of operations or the rules for working with exponents. She multiplied the bases and multiplied all the exponents. So she multiplied the bases and then multiplied all the exponents. That reason why she got that answer B incorrect. So in this case, I can write Tanya did not use the order of operations or the rules for working with exponents. And then she multiplied the bases, and then she got that answer incorrect. So that's your assignment. And if you have any question, you can email me as always. And I'll be waiting for questions, and I hope you have a great day.